Base 2 is also called binary. Bi is 2. And okay, so let's think about our other number systems. Base 10 had 10 digits, base 5 had 5 digits, so base 2 is going to have 2 digits. Cool, only 2 digits. But it's also a little scary at the same time because there's only 2 digits. What are the digits? They are 0 and 1. There is no 2-digit on its own. And then I got to think in groups of 2. Group by 2. If I group by 2, that means I have powers of 2. And writing them in reverse order, like we do base 10 numbers, we're going to have our 1's place, and then our 2's place. 2 groups of 2 is 4's place. 2 groups of 4, 8's. 2 groups of 8, 16's. Right? These are all powers of 2. 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, and so on. So I'm going to write down a binary numeral. 1, 0, 1, 0, 1 is a possible base 2 number. What does that number mean in base 10? Well, we have enough information above to expand it. So I'm just going to remind myself, these are the 1's, those are the 2's, those are the 4's, those are the 8's, these are the 16's. I'm not going to bother writing that I have 0 8's. I'm just going to write the ones I do have. I have 1 16, and I have 1 4, and I have 1 1. So 16, 4, and 1 is, on a good day, 21. So 1 0 1 0 1 is how one would write 21 in base 2. Yeah, so I just skipped over the 8's and the 4's because there was none of them. Technically, the expanded form should have those zeros in there, but it's not going to change the answer. Yeah, so that's not a proper expanded form. That's a quick one to get me an answer. The proper expanded form should look like this: 1 times 16, and 0 times 8, and 1 times 4, and 0 times 2, and 1 times 1. Still going to get 21.
So we had to fill that out when we
Let's try counting in base 2.
I have a quick question.
What's up?
Well, so for the activity, the first one I wanted to do today,
Yeah.
it asked us to list 30 of the numbers, but then the first question is like list 14 of them.
15 or 10. First one was 10.
Well, it's less than the one that's like
Yeah.
in the first problem.
Yeah.
Do you want us to list it twice then?
Sure.
Nobody just texted me about it and I like catch them.
I'd figure it out either way, but I think since you're counting, it makes sense to start at 1, but I'm okay with you starting later.
Well, no, like how we list them twice.
Essentially, because the first question is count to 10, the second
Yeah.
question is list to 30.
So you want us to list them out twice? Or can we just write out?
1 through 30,
Yeah,
and say this is part 1 and part 3.
yeah.
Sure. I'll take that too. All right, so I'm going to try and count. 1. Let's use a different color. 1. What's after 1? 2. It's a group of 2 and no 1's. 3. Group of 2 and a 1. 4. I need a new place. 1 0 0. There's 4 in binary. There's 5, a 4 and a 1. 6 would be a 4, a 2, and no 1's. What number is that? 1 1 1. 7. That would be 4 5 6 7. A 4, a 2, and a 1. How would you write 8?
Oh, 1,000. So 1,000.
Don't call it 1,000.
Yeah.
1000. Yes, it's 1 8 and no fours, no twos, no ones. Yeah. So here's the hard thing about binary is your 1 is like a 9. As soon as you get to 1, you got to go to the next place. It's kind of mind blowing.
That's 1 through.
This is 1 through 8. Yeah, suppose we want to list the first 10, we got a couple more to do. So 8 would be an 8 and a 1, so it'd be an 8, no fours, no twos, and a 1. I'm sorry, 9, that would be 9. So 8, 9, 10 would be 8 and what? 8 and 2. No fours, no ones. So these are the first 10 counting numerals in binary. First 10, maybe I should write 10 a different way, like that. Binary numerals. Let's try to convert a number from base 10 to binary. We just look at how to convert from binary to base 10. That's not bad. Just got to expand with powers of 2. I'm not going to pick too big a number because in binary it gets very long, very fast. So how about 25 in binary? It's 2. I'm going to choose to do it with my repeated division. So I would say, okay, 2 goes into 25 how many times? Well, 2 goes into 2 once, 2 goes into 5 twice, remainder 1. Cool thing about binary, the remainder is either 0 or 1. Kind of simple. And then I just keep going. 2 goes into 12, 6 times, remainder 0. 2 goes into 6. Oops, I'm going to switch color. Bless you. 2 goes into 6. Oh, maybe I need to switch color there. Using myself with color. All right, 2 goes into 6 3 times, remainder 0. 2 goes into 3 1 time, remainder 1. And then 2 goes into 1 no times. That's the key that you're done once you write your remainder. So the answer looks like it's 1 1 0 0 1. 1 1 0 0 1. Let's check it. So to check it, I need to identify the places. So I'm just going to write that above. I have my 1s, my 2s, my 4s, my 8s, and my 16s. So according to this, I need 1 16 and I need 1 8. I don't need any 4s or 2s, but I need a 1. 8 and 16 is 24 plus 1 is 25. It checks. Alternate way to do that is to start listing powers of 2 and then start using the biggest ones. So the alternate approach on this, I would write out powers of 2. 1, 2, 4, 8, 16, 32. I got to find the one that's too big so I know the biggest one to use. So then I would say, okay, how many 16s are there in 25? And it's either 1 or none each time. That's the nice thing about base 2. So there's 1 in there. Subtract 16, you got a 9. And then I move on to 8. How many 8s are in 9? Well, there's 1 of them with 1 left over. Since I have 1 left over, who cares about 4s and 2s? They just ain't there. So I can see I get 1 16 and 8, no 4s, no 2s, and a 1. So I still get the same answer. Slightly different way of thinking about it. In this case, it seemed like slightly less work. You never know until you start playing with it. What's going to happen? Kind of like we did with 5, but now we have to think about 2s. Is this a little mind bending?
Yeah.
Good, because kids in your classroom are going to have their mind bent every day when you do math with them. So we're kind of getting back in their shoes to remember what it's like to struggle with math. And hopefully better understand our number system. Question your number system? Yeah, I mean, when I learned this stuff, I was like, my mind was totally blown. Why? All right, here's another cool one. Computers do things in base 2 in the background, and humans have made all these fancy interfaces to sit over it, but really in the background, it's all these computations based on 2, and I get pretty pictures and videos and TikTok and, whatever. Color on computers, or digital in general, is base 16. Okay, base 16. How many digits would we want to have for base 16? 16 of them. Okay, let's start listing them. Our digits. This is where things get interesting. Well, we want a 0 and a 1 and a 2 and a 3 and a 4 and a 5. I like these digits. Let's keep using them. 6, 7, 8, 9. Ooh, I need another digit. Now, I can't say a digit is 10 because that's 2 digits. No, can't do that. Sorry. You got to make up 6 more digits. Common thing to do is use letters next. A, B, C, D, E, and F. Okay, if that's the case, in base 10, so an A in base 16 would be what in base 10? What's after 9? Ah, that would be a 10. And the B would have to be 11 in base 10. And the C would have to represent 12. And D would represent 13. And E would represent 14. And F would represent 15. How the heck do I represent 16? 1, 0 would be 16 because it's a group of 16 and no ones. But these are the digits that are commonly used for base 16. And like if I go out to the internet and like, let's take this pretty button right there. If I go to inspect the page source, then I'm going to find a color. And this color is right there. Let's copy that. That's that color I see there. So that suck up a little bit. This is a base 16 color numeral on a computer. And they're saying the color is 0B874B. It's giving me a hexadecimal color. Now, colors are a little more complicated than just straight base 16. The first 2 digits here are how much red to use. The next 2 digits are how much green to use. And the next 2 digits are how much blue to use. And blended together, they give me that greenish color I was just seeing on the screen. Okay. So the way it works in computers is you have 3 2-digit hexadecimal numbers to work with. All right, so let's see. What's the biggest digit in hexadecimal? What's the biggest 2-digit number you can make? Like in base 10, it's 99. What would it be in hex? What's the biggest 2-digit number?
Be double F.
It would be double F. Yeah, that's the biggest 2-digit number. So biggest 2-digit hex. Often we call it hex instead of hexadecimal. Numeral is FF. How much is FF in base 10? Okay, well, we know base 16 means group by 16. So this means I have F16s. How much is F worth again? 15. So I have 15 groups of 16 plus how many ones? 15, yeah, 15 ones. Okay, I need a calculator for 15 times 16. I can't do that in my head today. 15 times 16 is 240.
255.
So if I add that up, that would be 255. What's the next number after 255?
Yeah. Because there isn't one.
Well, in base 10, sorry, we'll get to hex in a second. After 255 is 256. And 256 happens to be the next power of 16.
This isn't that weird to me, because I played a lot of video games as a kid.
Yeah.
And you color menus, like they simplify it because it has to have a simple user interface.
Okay,
So it's either 0 to 31 or 0 to 255.
okay, yeah,
You
right.
can't have math, have numbers, or
And
letters.
Letters and numbers, and it's not algebra, yeah, so
And
this is,
colors.
yeah, so like there is a, you know, you have to, the computers have to, and humans have to be able to do that do digital color stuff. Ultimately have to do computations with these things to make colors work out.
That's
Nice.
why I'm not
On
in any
computer.
technology.
Yeah, so yeah, this is not for everybody, granted. But you know, if I'm counting in base 16, right, I'm gonna at some point I'm gonna have FD, and after FD is FE, and after FE is FF. And that's like 99 in base 10. So the next counting number has to be 100. And again, what would that be? That would be 0 1s, 0 16s, and the next place happens to be 16 squared. And 16 squared is 256.
Does make color matching very easy though.
Yeah, it does.
You were mad when they added letters. Now there's colors
Colors with letters and numbers.
that.
Okay, I think it's pretty awesome. There's one homework problem that has you look at a hexadecimal color.
If you just go into like your paint program, that's you can make the colors based on those two.
Yes, you can, yeah. Yeah, and there's different versions of it. Some people like the decimal version of colors, which means each red, green, and blue is 0 to 255 in the decimal version, instead of 0 to FF. But the hex version is the more common way to express colors on the internet, and in most applications like games. It ends up being mostly hex. But it could be in decimal. The decimals just be structured slightly different. Yeah, this part's kind of mind blowing.
Hopefully we just use
That's-
this too.